Welcome to Lecture 2. We are going to pick up where we left off at the end of Lecture 1, and we're going to continue with the unit conversions, and then we're going to do the concept of density. So we are going to start off with conversions involving squared or cubic units, which makes students just quiver in fear. And most conversion tables do not give the conversions for squared or cubic units. Volume being an example of a cubic unit, but it's no problem. You are going to focus on what you're doing. You are going to focus on the fact you're going from meters to millimeters, for instance, and then you will cube the conversion factor. Okay, so I want to go, so if I were going from meters to millimeters, 10 meters, they are 1,000 apart. This 1,000 goes with the smaller, and which is what I want on top because that's what I'm trying to go to. So just in review from Lecture 1. Okay. Now, what if I wanted to do a cubic? All right, like I'm doing in this next example. I want to go from meters to centimeters. That's how you need to think about it. So you would say, okay, they are 100 apart from one another because meter is a base unit, centi is 10 to the minus 2. There are 100 of these smaller ones in the larger one. So 100 centimeters, and oh man, do that. 100 of the smaller in the larger. So you're going to set your conversion factor up that way. 100 of the smaller in the larger. Then you'll cube the conversion factor. Now you're not going to do anything with the original number. It's already cubed. Okay? So when you do the math, you're going to say 10 times 100 cubed divided by 1 cubed, which is 1. So 10 times 100 cubed gives you, in scientific notation, 1 times 10 to the 7th. And now your meters cubed have canceled and your answer is in centimeters cubed. So focus on the basic relationship and then do what you need to do, either squared or cubic. All right. Another type of conversion we're going to do here at the beginning is a multiple step conversion. So here's one that we've worked out in the notes, but let's break it down and then we're going to do some practice. So you've got a hamster wheel that is 25 centimeters in diameter. In order to exercise a fat hamster, it has been determined that the hamster needs to run 100 meters every day. So what I'm looking for in this problem, and it's a word problem that makes students, again, quiver in fear, is what is the question? How many times around the wheel? So let's focus on that. What are they really asking for here? Well, I know that one time around the wheel is 25 centimeters. So we're essentially looking for wheel turns, or I'm going to call them laps. Okay? And so I want to know how many laps around the wheel. So how is lap related to something else in the problem? So I'm going to start off. One lap is 25 centimeters. And since I want laps, I'm going to write that conversion factor in this way. One lap on top, which is the thing I want, the question, right there on top, and then what it's related to in the problem, which is one lap is 25 centimeters, that part goes on the bottom. Now your job is to start getting rid of things, starting with centimeters. Well, how can I get from centimeter? How can I get rid of centimeters? I want to end up only with laps. Well, look back at the problem. I've got 100 meters in here. All right, I've got to work that in. So go from centimeters to meters. So that's what I've done here in this second term. And since centimeters is on the bottom, it needs to be on the top in my conversion. So 100 centimeters on top per meter. And so now centimeters is gone. Now I've got to get rid of meters. Then multiply times that 100 meters, and the meters cancel out, and everything cancels except for laps. All right? And by focusing on the units, now I will do the math. 100, 1 times 100 times 100 on top divided by 25, which is 400. So without knowing a formula or anything like that, or stabbing in the dark, as many students do, trying to find a multiple choice answer on a test, for instance, focus on the units and it will tell you what to do with the math. All right, so we're going to go ahead and do this practice. which I've already brought into the notebook program. So here we go. And the first one is a cubic conversion, right? So we are in decimeters cubed, and they want us to go to centimeters. So what we're really having to do here is go from decimeters to centimeters, okay? I want to get out of decimeters and into centimeters. How that's a metric to metric. How are they related? This is 10 to the minus 1. This is 10 to the minus 2. So they are 10 apart from one another. Centi is smaller. So there's 10 centimeters in a decimeter. So now let's get started. 15,615 decimeters cubed times, I want to get out of decimeters, so that one goes on the bottom. The 10 centimeters goes on top. And now I will cube this. And then I will get out of decimeters cubed and into centimeters cubed, which is what they asked for. So 10 cubed, 10 times 10 times 10 is 1,000, times the 15,615. I end up with a big number that I'm going to put in scientific notation. 15,615 times 1,000. Ask me and I'll show you how to get your calculators into scientific notation. Now, question, how many significant figures? The number I'm given in the problem has 5 significant figures. Do not use conversion factors for significant figures. Use the number given in the problem. So I could report this as 1.5615 times 10 to the 7th, and I would not be wrong, centimeters cubed. Okay? All right, moving on. Now, in number 2, I've got a metric to metric in B, and the other 3 are English to metric. So you need to go to page 24 in your book, and in the lower left-hand corner, you will see the conversions between, for instance, centimeters and inches, and liters and quarts, and millimeters and inches, and so on. They're not all there. You may have to do 2 steps. I believe you will in D. So let's start with A. I want to get out of centimeters, and I want to get into inches. All right, so the inches part needs to be on top, and the centimeter part needs to be on the bottom. Now, whatever your, let's see if I still have. All right, there is my metric, and I'm trying to do inches and centimeters, right? Inches and centimeters. So down here up here at the top, inches and centimeters, 2.54 centimeters. Now whatever number is next to a unit, it has to stay with that unit. So wherever I put centimeter, 2.54 needs to stay with it. Okay? Wherever I put 0.6214, wherever I put miles, I need to put the 0.6214 with miles. Okay, students gonna get that confused. All right, so it's 2.54 centimeters in an inch. So that part is going to go down here on the bottom. The 2.54 stays with the centimeter. So 2.54, 1 inch, so 154 divided by 2.54. And I will have my answer in the correct unit. 60.6 inches. Significant figures, I had 3. That's 3 significant figures. All right. B, kilograms to grams. This is a metric, so do not look at the lower left-hand corner on page 24. Think back to your prefixes. These are 1,000 apart from one another. There are 1,000 grams in a kilogram because it's smaller. So that 1,000 stays with the grams, and it has to be on top because that's what I'm trying to get to. And my answer here for B is 3,140 grams. This was 3 significant figures. If I put a point there, that'll be 4. I could do 3.14 times 10 to the 3rd. Now I'll have the correct number of significant figures and the right magnitude of the number. Okay? We'll put C up here for number 2. C, liters to quarts. And I want to get out of liters So liters part needs to be on the bottom. Quarts part needs to be on top. Go back to my little chart. Liters and quarts. There it is right there. 1.057 quarts stays with quarts. 1.057 what? 1.057 quarts stays with quarts. And that needs to be on top because that's what I'm trying to get to. I'm trying to get out of liters. So 3.5 times 1.057. And my calculator says 3.6995. I'm going to say 3.7. This has two significant figures. I ignore significant figures in conversion factors and look at the number I'm given and my answer. Don't put a number down without putting a unit behind it. It's 3.7 quarts. D, last one, millimeters to inches. Now, if you go back to page 24, which I'm not going to do because I know it's not there, there is no millimeters to inches. Now, some of the smarties might automatically have already put this in centimeters, and you only got to do one conversion factor. I'm going to do two. I'm going to go from millimeters to centimeters, so then I can use this conversion factor right here. Do I want to use it the same way? I do, because I'm trying to get to inches, so inches is going to stay on top. But first, I'm going to get rid of millimeters and get into centimeters. So centimeters needs to be on the bottom. They are 1 power of 10 apart, so there are 10. Whoops, did that one wrong. See, I knew that if I continued that, my millimeters would not have canceled, so that is not correct. I need to flip that conversion factor. Okay. And the 10 stays with the small one. So it is 1 centimeter has 10 millimeters. Okay. Then I'll multiply it times this same conversion factor. Okay. So that is 10.9 centimeters, and I'll put it here, then I'll erase it. 10.9 centimeters. I just don't have room to put another term out here. 10.9 centimeters times 1 inch on top, because that's what I'm trying to get to, over 2.54 centimeters. Centimeters cancel. 10.9 divided by 2.54. You know you've done it right, and you didn't stab around in the dark. The 3 significant figures given in the original problem, so I'm going to go with 4.29 inches. All right. Now, let me just, those of you who learned how to do picket fence, let me do some erasing and show you how you would set this up. And maybe this is a method that some of you who aren't familiar with it might like as well. So I'm going to do the same one, D, but I'm going to string it all out. Okay, so picket fence is this thing. All right. Now, I'm not very good at picket fence drawer. So there's 1, 2. I've got 1, 2. I need 3. Now, of course, you can do more than you need. That's okay. So I am starting out with 109 millimeters. Now you can think of it as being over 1. Then I want to get rid of millimeters. So the millimeters goes on top, the centimeter goes on the bottom, and we determined that this was the case. Now I want to get, so millimeters are gone. Now I want to get out of centimeters and into inches, and it's 2.54 centimeters per inch. And that tells me 109 divided by 10 divided by 2.54, and we end up with our 4.29. So this is what I'm referring to when I've said picket fence before. All right, since we have that up there, let me do a little erasing. And I'll put my answer up there. And so I can erase down below, 4.29 inches. All right, erasing here. Number 3. I'm going to scroll down a little bit. All right, we've we've got 10 kilometers. I'm looking for the question. How many minutes? I want time on top. Where do I have time? I don't have any time here, but I've got some time here. 7.5 miles per hour. So instead of writing it like this, that's not going to help me. Hours is on the bottom. Flip it over. Put the hour part on top. It is related to this on the bottom because this is what I want and it needs to be on top. Now, get rid of miles and do everything you have to do so that when you're done, all you have is hours. You have to get rid of everything else. So what can I do to get rid of miles? Well, I've got miles and I've got some kilometer information here. So I think I need to go from miles to kilometers, which means that miles needs to be on top because I'm trying to get rid of it. Kilometers needs to be on the bottom. I'm going to go back to my little table, page 24, length, miles and kilometers. There it is up at the top. 1 kilometer, the 0.6214 stays with the miles. 0.6214 miles on top, 0.6214 miles per kilometer. So now miles are gone. And I need to get rid of kilometers. I have that in the problem. There it is, 10 kilometers. Kilometers are gone. Everything's gone except for the hours. Oh, once minutes. My bad. Not done. It's okay. Hours needs to be on the bottom. Minutes on top. And now I've got what I want. But even though I had time in the wrong unit, it was in the right place. If it had been on the bottom, I still wouldn't have come out with minutes. So you have to get the question unit you want on top. Now, this times this times this times this divided by all of this. So this is how I'm going to talk you through how I would put this in my calculator. I always like to put numerators in first. So 0.6214 is my first real numerator. I'm not really counting that one. So 0.6214 times 10, and I'm pressing the equal. And then I'm saying times 60 equals divided by 7.5 equals. Significant figures in the numbers given in the problem, I have 2, so my answer is not 4.9712 times 10 to the first. It is going to be 5.0 times 10 to the first, or I could just say 50. All right, so 50 minutes is my answer, and that is 2 significant figures. All right. Number 4, doing some square measurements here, and I'm starting off with 195 meters, and the first one they want me to do is get it into kilometers, out of meters and into kilometers. Okay, so let's do it right here. 195 meters squared, don't let it scare you. I want to get out of meters and in kilometers. Just focus on that, meters and kilometers. Where does the meter part need to be? On the bottom. Kilometer part on the top. How are those two related? 1,000 meters in a kilometer. They are 3 powers of 10 apart from one another. Now, since I'm squaring, I'll square that conversion factor. All right? And when I put it in the calculator, there's a couple ways I can do it. 195 divided by 1,000 squared. Most people have a squared, key that's pretty easy to get to, and you don't need to do any parentheses or anything. And my answer is 1.95 times 10 to the minus 4. And what is my unit? It is kilometers squared. All right? You try B and C and come back. B, 195 meters squared. What I'm given down first, I want to get out of meters on the bottom and into decimeters. They are 1 power of 10 apart from one another, and deci is smaller, so the 10 goes with the deci. And then I'm going to square it. So it's 195 times 100. So that's 195 with 2 zeros. I want 3 significant figures. So best thing to do is to put it in the calculator, and it's 1.95 times 10 to the 4th decimeters squared. Right? And then C. I'm going to do a little erasing above. Do my C. (195) meters squared. Now I'm trying to get into centimeters. Centimeters needs to go on top. Meters on the bottom. They're 100 centimeters in a meter. And then square the conversion factor. So 195 times 100 squared, 1.95 times 10 to the 6th. 1.95 times 10 to the 6th centimeters squared. Okay, and really, I'm going to put it up here, lower upper left, 1.95 times 10 to the 6th centimeters squared. Sorry about writing it so crazy. All right, one more problem. And then we got density to do, I think. Yes. The average U.S. farm occupies 435 acres. The question is how many square miles? So then I'm given some stuff here, A and B. And I want square miles. So I'm looking for miles. Miles is right here. So I'm going to start with that. I'm going to put 1 mile over 5280 feet. But I don't want miles, I want square miles. So I'm going to square this. And now it gets the unit I want on top, and now I've got to get rid of square feet. So where is square feet? There it is. And now that part needs to be on top. The 43,560 stays with the feet squared, and that goes on top, and 1 acre goes on the bottom. Feet, cubic square feet are now gone. And now I need to get rid of acres. Where's acres? There it is. 435 acres. And once I do that, I've gotten rid of everything except for square miles, and I'm done. Now, putting this in the calculator. This number here, 43,560, I'm not squaring it. It's already squared. Okay, that number has a square unit on it. You don't do anything to 43,560, so put it in your calculator. 43,560, always like the numerator first, times 435 equals, now divided by 5280 squared equals 0.68, 3 significant figures. That's my smallest right here with this number. So 0.680 acres. All right, now, this next question is kind of silly, but we'll go through it. It wants to know percentage, and we're going to do quite a number of percentages in this class. And percentages are always part over the total times 100. So total was given to you. It is, so that's on the bottom, 3537, oh my bad here, this was square miles, 3537 million, 1, 2, 3, 4, 5, 6, square miles is the total. The part is what you got in A, 0.680 square miles times 100. It's going to be really small. 0.68 divided by 3537, 1, 2, 3, 4, 5, 6. I did that right. And I get times 100. Oops. And I get 1.92 times 10 to the minus 8. Very, very small. All right, so mainly the reason I put that in there was because percentages will keep doing them over and over again. Okay? All right, back to the notes. We've got density to talk about. Okay. Density. Density is going to be a unit that is a ratio, and it is a derived unit because it comes from other basic units, that being mass and volume. So one of the things I'd like to talk about for just a couple of moments is getting students to understand the difference between mass and volume and some idea about density in terms of states of matter. So I've got some questions here, and then I've got a link. If you need to review the difference between solids, liquids, and gases, I've got a link for you right here. Okay, 2 links in fact. One is a website here, this first one, and the second is a video. Okay, but we've got a series of questions just to kind of remind ourselves of the differences between mass and volume, and then the idea of density. So which state of matter, solid, liquid, or gas, occupies the most volume? It would be gases. In gases, particles are spread apart from one another, unlike in solids and liquids where they're touching. All right, so gas would be the answer to that. If you had 10 grams of wax, which state would occupy the least volume? Well, that would be a solid. And the most would be gas. Liquids in the middle. So which state of matter has the lowest density? Density is mass over volume. So the one that has the smallest volume will have the greatest density. So the greatest density will be the solid. The lowest density will be the gas because it has a high volume, and that's on the bottom part of our ratio, which is what density is. Grams per volume. Which has a greater mass, a ton of feathers or a ton of bricks? And the answer is they're the same because they have the same mass. Difference between mass and weight. Weight is the pull of gravity on mass. These are 2 masses. English system mass, but it's a mass. If I were to take that ton of feathers, either one or both, to the moon, then it would be different because the pull of gravity would be different. So on the moon, you still have a ton of mass, but you don't have as much weight because weight is the pull of gravity on mass. Which occupies more volume, the bricks or the feathers? The feathers do. They have spaces in between. They're not densely packed, so they have a much smaller density than the bricks do. Density can be seen as a conversion factor between mass and volume. It is an intensive property that does not depend upon the state of matter. It does depend on the state of matter. We just determined that. It does not depend on the size of the sample. All right. So if I have 5 grams of copper, that has the same density as if I have 2 tons of copper. That ratio never changes as long as you stay solid in terms of copper. If we're talking about nitrogen gas, it doesn't matter if I have 5 milliliters or centimeters cubed of nitrogen gas or a metric, a kilometer cubed of nitrogen, you're still going to have the same density. All right, some different densities. Air, made up of gases, has a very small density. Notice that the units for density is grams on top, volume unit on the bottom. So air, because it's a gas, has a very low density. Ice floats on water, so it has a density less than 1. The density of liquid water is 1. And then you have other things. Most wood floats on water, so the density is somewhere between 0.6 and 0.9, but less than 1. Everything with a density greater than 1 is going to sink in water. Everything with a density less than 1 will float. All right, so we're going to use density as a conversion factor, and so I do have this practice copied, and then that's going to conclude lecture 2 for us once we've done that. So this isn't a very long one. Back to my notebook. Go. And my next page is the density. Okay, so here's our mass. Here's our density. And the question here is, what is the volume? So focus on the question. Where's volume? Here's volume right here. So instead of me writing 0.788 grams over centimeters cubed, I'm going to write it this way because I want that volume term on top. Now, can I do this and be done? No, because these two things don't cancel out. So I need the conversion factor between grams and kilograms. And if I set it up right, I'll do the problem right. And if I set it up right, grams will go away and kilograms will go away. So grams is on the bottom, grams needs to be on the top. Kilograms is on the top here, it needs to go on the bottom. How are they related? They are 3 powers of 10 apart, and grams is smaller, so the 1,000 goes with the grams per kilogram. I don't want you to be confused about this underlining I did earlier, so let me take that out. And now I'm going to do the math as dictated by setting up the problem. So 18,754 times 1,000 divided by 0.788. And I said equal after I did the multiplication. And my answer, significant figures, I have 3 here in the density given. So my answer needs to have 3, not the 2.379949239 that my calculator says. 2.38 rounding to 3 times 10 to the 7th centimeters cubed. So I can use density as a conversion factor. In this next problem, I'm just going to determine the density, and densities need to be in grams per centimeters cubed or grams per milliliter. All right? These two things are the same. And I will try to remember to bring in a demo to show you that. Well, hopefully I've remembered before you saw this video. Excuse me. Okay, so I need to get a volume out of this. It's a board. Length times width times height, and I will have centimeters cubed. And then I need to get out of kilograms and into grams to get density. Okay, so grams goes on top. So what I'm going to do, first of all, I'm going to get this volume. So I'm going to multiply those 3 numbers. 5.54 times 10.6 times 199. And I have 1.169. Now let me make a comment here about significant figures in the middle of a problem. Don't worry so much about significant figures in the middle of a problem. In fact, carry those digits out to your heart's content. You will round at the end. All right, so there's my volume. Okay, I'm going to do some erasing. All right. And this is what I want to end up in. Okay, so I'm going to leave that there. I'll go ahead and start with the 28.6 kilograms. And I need to get rid of kilograms, and I need to get into grams. And the grams part needs to be on the top. 1,000 grams into kilograms. 3 powers of 10 apart. So now I've got grams. And then here's my volume. You can do it this way. Or you can do it where you convert kilograms to grams and then take that and divide by that. You're doing the same thing, okay? As long as you do it right, set it up on a quiz, which I think, as you know by now, the quizzes are these problems in the lectures. You'll have to show your work, including your units. And I'm likely to change the numbers. Divided by, I pressed equals after I did the times 1,000, 1.169 times 10 to the 4th. And I get 2.45. And 3 significant figures is good. 2.45 times 10 times 10 to the 0. So 2.45 grams per centimeters cubed, because that's what I have, grams over centimeters cubed, and that's what density needs to be. Okay. Number 3. I'm looking for the question, what is the mass? So where is mass in this problem? There it is. It's part of density. And because I want mass, I'm going to leave it as is. I'm not going to flip it. So it's 2.50 grams over centimeters cubed. Now, should you write it like this, or should you write it like this? Often when I put it in a problem, it's just easier for me to put it in a problem by putting it in like this. However, when you are canceling units, I think it is so much easier if you write it like that. Just a little comment. Okay, so now you see that centimeters cubed needs to go away because I need to get mass. And I don't see anything else with centimeters cubed in it. I see liters. And I know that liters can be converted to milliliters, which is the same thing as a centimeters cubed. So I could go ahead and put the 15 liters in there, but I'm not finished. Now I need to get rid of the centimeters cubed or milliliters, okay, and that needs to be on top. So there are 1,000 milliliters in a liter, or 1,000 centimeters cubed per liter. I put the centimeters cubed on top, so it would cancel with it on the bottom. Same thing here. And I just have to multiply those 3 numbers. Did I memorize a formula, or did I memorize how to rearrange the density formula? No, I used the units to help me solve the problem. And my answer is 3.75 times 10 to the 4th grams. Okay, 1 more and we're done. Nope, 2 more and we're done. All right, number 4. What is the mass of water? That's what we're trying to get to. There's some mass right there. So I'm going to leave it alone. 1.03 grams per centimeters cubed. 1890 liters is a volume. And so we're essentially going to be doing exactly the same thing here that we did up in the previous problem. And then go from liters to centimeters cubed, or get rid of both of them by setting this conversion factor up correctly. So that cancels, and there you go. And I get 1.95 times 10 to the 6th grams. All right. Last one. Spanish mahogany. Much nicer than a Honduran mahogany. A hope chest has this volume and this mass. Identical hope chest has this mass. What is the density? So you want the density of the 2, and we're going to do this in grams per centimeters cubed. So we're going to have to do some unit converting. So I'm going to start with the Honduran, and I'm going to take my 349 kilograms, that's a mass, and I'm going to divide it by the volume. But I don't want a density in kilograms per meters cubed. I want it in grams per centimeters cubed. So I've got to convert them both. Kilograms needs to go away. It needs to be on the bottom. I want grams on top. And they are 3 powers of 10 apart from one another. All right? So that takes care of my mass. Now this. Meters to centimeters. We're dealing with cubic. Focus on the basic unit here. I want to get rid of meters. It needs to be on top. Centimeters needs to be on the bottom. Centimeter is smaller. They are 2 powers of 10 apart. 100 centimeters in a meter, and then because we're dealing with cubic, I'm going to cube that. And now my meters cubed goes away, and I'm going to end up with grams per centimeters cubed. All right? So I'm going to take care of my numerators first. 349 times 1,000 equals, divided by, I'm going to put this in parentheses, 0.648 times 100 caret 3 for cubed, close parentheses, and my answer is 0.549 grams per centimeters cubed. All right? Spanish has a mass of 550.8 kilograms, and it says identical, so that means that the volume is the same. So you're going to do exactly the same conversions you did here above. So you're just going to repeat. Okay, so we can get it into grams per centimeters cubed. Do a little erasing there so you're not confused. All right, and then putting it into my calculator, 550.8 times 1,000 equals, divided by, in parentheses, 0.648, don't need to cube it, that number is already a cubic measurement, times 100, and I'm going to cube that by raising it to the third power, close parentheses, and my answer is 0.850, and that makes sense since it said that the Spanish mahogany was denser than the Honduran mahogany. All right? Big difference in density. And that concludes Lecture 2.